This is Algebra 2B, Lesson 1, Quadratic Functions. So a quadratic function is a polynomial of degree 2. We've seen that before. Basically, we're going to have an x to the power of 2 in our equation. We talked about those in our transformations of functions chapter. Anytime we had an x squared, it gave us a u shape, and we called that u shape a parabola. Now, as we've seen, we can move that around. He doesn't have to be right in the middle there. That u shape, right, that parabola, I just want to identify a couple key points, like the vertex, whether or not that is a right side up u or an upside down u. That vertex is going to be the top or the bottom of the u. We have the y-intercept, wherever the u-shape crosses the y-axis. Every parabola is always going to have one y-intercept. And then we also usually have a couple of x-intercepts, wherever our u-shape crosses the x-axis. Now, I drew this one a little lower than I intended to, but let's say that vertex hits right on the x-axis, right? Then our parabola only has one x-intercept. In this case, there are two x-intercepts, but depending on how you translate that up or down, you could also have no x-intercepts. So looking at a couple different formats, we're going to start with general form. The general form of a quadratic is something times x squared plus something times x plus something times c. We call a, b, c our parameters. A can be any number except 0. Okay? If a was 0, that x squared term would completely go away and we'd no longer have a degree 2 polynomial. B and c can be any number you want. They could even be 0, which would be the case where you'd have just x squared, because your x goes away when you times it by 0. You have no constant if your constant is 0. Vertex form we've seen before. When we were translating our parabolas, we were moving them left and right, we were moving them up and down. So the values that we put in for h and k, that would be where the vertex of the parabola is located. And then last is factored form. So that a can kind of move around. Sometimes he's in the parentheses, sometimes he's out in front, but whatever your x-intercepts are, and we actually have lots of names for those. Sometimes we call them factors, sometimes we call them roots, sometimes we call them zeros, but whatever your x-intercepts are, root 1, root 2, those would be the values that would go in for that format. Couple more definitions. We have our minimum and our maximum. So based on your a value, remember a cannot be 0, but if your a is a positive number, then you will have a u-shape that opens upward, because all of the values on the parabola have to be higher than your a value. Or if you have a negative a value, then your parabola will actually have a maximum, because all of your values will have to be lower than that top value. All of our parabolas are u-shapes. That means they're symmetric. The left side and the right side, they're always going to match up, and we can figure out the axis of symmetry, right? That dotted line that would kind of be right in the middle, if I drawn him a little nicer. Using general form, we can substitute in negative b over 2 times a, and that'll give us the formula for whatever shape we have drawn. It'll show us exactly where the middle of our u-shape is. Now, the vertex of a parabola is always going to fall on that axis of symmetry. So if we have vertex form, guess what? We already have the vertex. But if we're given general form and need to find the vertex, first we can find the axis of symmetry, because whatever we figure out there, that's going to be the x coordinate of the vertex. And then to find the k, we can substitute the h value that we just figured out. We can substitute the x value of our vertex into our function, and that will give us the output value, the y value for the vertex. That's a lot of words. Don't worry. I'll show you on an example when I get down there. A couple more. X-intercepts. So I showed you what one x-intercept looks like, what two x-intercepts looks like. So here we'd have two x-intercepts if our parabola crosses in two places. A parabola can have one x-intercept if that vertex falls right on the x-axis, but we can also have no x-intercepts, depending on two different versions, whenever our entire parabola is on top of the x-axis or below the x-axis. And then last, we have our y-intercept. There is always going to be one y-intercept, okay? To figure out that y-intercept, generally, you want to evaluate your equation at 0, because wherever x is 0, that's going to be your y-intercept. If you're given a equation in general form, that's really nice, because if you put a 0 in for x, a 0 in for x, 0 times anything, both of those terms are going to go away, and all you're left with is c. Okay. Let's try a couple of examples. Example A says, evaluate the function f of x equals negative x squared plus 2.4x plus 5.8 at the given input values. So what we're going to do is take the value that we're given, and we're going to substitute it in for all of the x's we might find in the equation. Now, I like to do that with parentheses, because especially in this one, if I have that negative in front, I have the negative in front, but I'm also substituting in a -2. I don't want to accidentally forget one of my negatives. If you have a calculator that knows order of operations, you can just type this entire expression in the calculator at one time. So let's see, I got this here. And I'm going to type in that equation. If you don't have a calculator that you can type in the entire thing, you can still do order of operations by yourself, like -2 squared, and then negative that, 2.4 times -2, and then add all three terms together. But with my calculator, bam, 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 just checking to make sure I typed it good, and I get -3. Okay? Letter B, we're going to evaluate f of 0. That means we're going to put 0 in for all of these x's. Now the nice thing about 0 is 0 times anything is 0. So that means, I'll still write it out, but if we have 0 times 0, and then 2.4 times 0, both of those are just 0. So my answer is just 5.8. And that's why I said, given something in general form, your c term, your constant, that is your y-intercept, because putting 0 in for everywhere else is going to leave you just with that c term. And then one more, we're going to put in a 3 everywhere we have an x. And we can use our calculator if we want to, order of operations if we don't have access. But I'm going to just type it in exactly like I see it. -3 squared, 2.4 times 3, and 5.8. That looks better. And I got 4. Example B, consider the function -2x squared plus 4x plus 30. What is the axis of symmetry? So I do have this graphed here, but we're going to use the formula from up top for finding the axis of symmetry. That was -b over 2 times a. So given an equation in general form, I have my a, I have my b, and I have my c. A is the number in front of the x squared, b is the number in front of the x, c is the number with no x. So I'm going to substitute in -4 on the top. And on the bottom, I have 2 times -2. So simplifying that a little bit, 2 times -2 on the bottom is -4. Same thing on the top and bottom, we'll divide to give us 1. So the axis of symmetry, and I'm going to add them to the graph, you probably could have figured that out from the graph, is right at 1. Okay? What is the vertex? So my graph on my scale, I know it's going to be somewhere between 30 and 40, but we're going to substitute the 1 and evaluate to figure out exactly what that y value would be. So -2, 1 squared, plus 4, 1, plus 30. Right? We're evaluating f of 1, because we figured out that the x-coordinate of the vertex is 1. So I'm just substituting that 1 in for my x's. And let's see here. 1 times 1 would be 1, times negative 2 would be negative 2. Negative 2 plus 4 would be 2. 2 plus 30, 32. Sometimes I don't trust myself, so I want to check that one on the calculator. We have 2. Negative 2. Negative 2, 1 squared, plus 4 times 1, plus 30, 32. So I already knew that he was between 30 and 40, so I think that looks good. The vertex is at 1 and negative 2. I think my line's not super straight. Anyway, because 1 should probably be here. That doesn't look right. Okay, so I knew that graph didn't look right, so I got the right graph on there. My bad. But now that this one actually matches the equation up there, it's much easier to see that the axis there lines up right where x is 1, and then our vertex there would be 132. Okay, so is this a maximum or a minimum? We know that a is less than, greater than 1, right? Less than. We know that a is less than 1. Because it is a negative 2. We can see looking at the picture too that this is a maximum point because everything is lower than that. What are the x-intercepts? Given an equation in general form, we don't have the tools yet to figure that out, but we're going to talk about that in a chapter or two. But looking at the graph, I can easily figure out what the x-intercepts are because I can see it crossing the x-axis once here and once here. Knowing that my scale is going by ones, that is 1, 2, 3, 4, 5. So one of my x-intercepts is at x equals 5. And then 1, 2, 3. My other x-intercept is at negative 3. And finally, what is the y-intercept? It's looking to be right about here. I can do a couple things looking at the graph, estimate it. I can look at my general form equation and evaluate the function at 0. And like we already talked about, if we are in general form evaluating at 0, all that goes away because that is just 0. And so my answer is at 30. Okay, I hope that wasn't too painful. I think that's all I got. Good luck on the exercises, and please let me know if you have questions.